Hello, everyone. I am Zhao Chuan. Today, let's get to know Ivan the Olorotitan. Olorotitan was a very strange-looking hadrosaur. To be more specific, it was a lambeosaurine duck-billed dinosaur. We know that hadrosaurs are divided into two principal groups. One is flat-headed, called hadrosaurines, and the other has all kinds of weird ornaments on their head, called lambeosaurine. The latter group is represented by Lambeosaurus. The crests of lambeosaurines were in various shapes, but in fact, they were all of the same structure. The nasal bone extending backward from the nose was formed by the rear partial frontal bone, and lacrimal bones on the sides, splicing together like a jigsaw puzzle, and fusing into a crest structure. This crest was often hollow and might have a keratinous structure covered outside, when they were alive, forming a more complex hollow structure organ that could produce sound. The crest of Olorotitan was similar to a fan shape, almost triangular. Some restorations reconstructed it to a square, because the collected skull was relatively broken. But the general shape is like this, square and sharp, a structure like this. It possessed the typical head features of hadrosaurs. For example, its face was relatively long, gradually narrowing in the middle of the nose, and widening at the front of the mouth. Because it became wider, we named them hadrosaurs, describing its wide mouth like a duck. From the fossil, this part is very flat. Now we know that the front end of a hadrosaur's mouth was not as flat as a duck as it looked from the fossils, but had a keratinous structure that extended downwards when alive, a bit like the structure of a bird's beak. And on the surface of the beak, there were some downward grooves or protrusions like ridges, which were convenient for it to grab leaves from the branches. When alive, this structure might have some serrations on the edges, somewhat similar to the teeth of Diplodocus. There were comb-like teeth in Diplodocus' mouth. When foraging, Diplodocus would use its teeth to comb down the leaves from the branches. There were many such serrations on the underside the mouth of hadrosaurs, which might be of a similar structure. Lambeosaurines shared some characteristics unique to this group, such as their very thick jugal bones, and relatively developed muscles connected between their mandible and jugal bones, indicating that these dinosaurs had a strong bite force and a certain chewing ability. In addition, hadrosaurs chewed differently from us. When we chew food, we move our lower jaw side to side, and the rear molars grind the food left and right. Hadrosaurs could not move their jaw left and right, but its two teeth. I use hands as an example. For example, the teeth on both sides of the lower jaw are like this, and the upper teeth are like this, grinding on the outside. When it closes its mouth, the upper dentary bone will bulge slightly outwards to form such a structure. It adopted this way to grind food. Therefore, when looking at the hadrosaur's teeth, you will see that their teeth often have an inclined grinding surface. Our general criterion for judging whether a dinosaur was carnivorous or herbivorous is to see if the animal's teeth have a grinding surface. If the teeth have a grinding surface, that is, the teeth were originally pointed, and some were found to be flat, this indicates that this dinosaur ate hard food with plant fibers. The teeth of carnivorous dinosaurs did not have a grinding surface because they ate soft meat and did not chew, so their teeth would not be ground. The other is the temporal fenestra behind the eyes. The lateral temporal fenestra of Lambeosaurines was usually tilted forward. In the middle of the low jaw was a relatively tall bone, similar to that of ceratopsians, indicating that this bone was attached to muscles, which enabled them to chew food more powerfully. In addition, the Olorotitan's neck was long. Some older restorations reconstructed it into a very slender neck, somewhat like that of a swan. Now we know that its neck looked much thicker than its bones when it was alive, because its rear half was connected with many muscles, making its neck look thicker, and it also had thicker muscles on both sides, so its neck was S-shaped inside. When it was alive, its neck appeared a little shorter and thicker than the skeleton. Next, we move on to its relatively narrow trunk. Many hadrosaurs were like this. We say it was narrow, does not mean it was as narrow as a ribbon fish, but in comparison with that of a stout carnivorous dinosaur, its trunk was slightly narrower. Its forelimbs were short, and the wrist was relatively long. It had 4 fingers on each hand. The ancestor of hadrosaurs was iguanodonts, which had 5 fingers like humans, and the thumb degenerated into a spike-like structure. But when it came to hadrosaurs, the spike-like structure disappeared, and so was the entire thumb, leaving 4 fingers. New evidence over the years shows that 3 of its 4 fingers were used for walking. Among these 3 fingers, the middle finger and ring finger were fused into one huge hoof, and the index finger was also wrapped into a hoof. These 3 fingers were all wrapped in flesh, forming one large hoof that split in half, sort of like a distorted pig's trotter. In the past, its little finger was believed to be used for foraging. Now it seems that the little finger might not be so flexible to do so, which might have no nails. It is a small structure like this. Most of the little finger was covered by skin, and only several bones were visible. When it usually walked, the forelimbs were used together with the hind limbs, and it walked on 4s. Hadrosaurs were very peculiar when they walked. Their 2 hands were normally facing each other like this, resembling a carnivorous dinosaur. When they walked, their body would lean forward a little, like this. When they stood on all 4s normally, the 2 hands were farther apart, and when walking, they became closer. Their hind limbs were much thicker than their forelimbs, and their thighs were very short, so if they run they would run very fast. Although hadrosaurs were quadrupedal when walking, they run on 2 hind legs, raising their front legs, as shown in this model. There were 3 toes on their hind feet. The first toe and the 5th toe had degenerated. There was a pad under each of the 3 toes, and another pad was located behind the 3 pads. So when you look at the footprints of the hadrosaurs, you will find that their footprints left on the ground were all full pads. It had a relatively long tail that was flat-sided. In the past, the reason for hadrosaurs' flat-sided tails was believed that this group of dinosaurs was good at swimming, and when hadrosaurs were discovered in the early years, people found that a layer of skin connected their fingers. People did not know that the linked fingers were for load-bearing, and in this way, the fingers were strengthened, but thought that there was a skin membrane between the fingers of hadrosaurs, like webbed feet. Together with the side-to-side flat tail, people believed that hadrosaurs were good swimmers. So in early restorations, you can always see hadrosaurs swimming in the water. Now we know that they walked on land, and the skin membrane in the past was caused by incomplete preservation of fossils. Its tail was flat-sided because the neural spines on the tail were very high, and so were the neural spines on the back. Just looking at the skeleton, it looked like a back sail structure, extending all the way to the tail. In fact, these elongated neural spines were to strengthen its body. The trunk of hadrosaurs was very rigid, with numerous crossed cartilage rods tied to the sides of the neural spines, which made its back not very soft. The same was true for the tail. There were also many bone rods tied to the neural spines on the tail, making its entire body look like a fishing rod. These bone rods could slide slightly under the skin, so the tail could still swing, but only in a small range. Finally, there were a series of protrusions on the back of hadrosaurs. This decorative structure was a bit like the spines of iguanas. Some specimens show that the spines are square, and some specimens show they are pointed. Since Olorotitan did not have such a complete soft tissue structure preserved, we don't know what its spines looked like. However, in the high probability, it also possessed such spines. By taking reference to most specimens, we restored them to be relatively square, not that sharp. Good, the above concludes our introduction to Ivan the Olorotitan. Thank you all.